Hey everyone, I wanted to make a little video here to supplement the word problems that we did. We did one in class and we didn't get to this one, so I wanted to run through this just to give you some more exposure, a little bit more thinking on how word problems can go. So let's take a look at this one. This is 2.7. It's from the notes, and it says the current population of a small city is 350,000 people. Due to a loss of jobs, the population is decreasing by an average of 250 people per year. How many years from now will it take for the population to decrease to 280,000 people? Now, I just made up the numbers for this problem, and the numbers are a little bit unusual. So I want to make a change in the problem just to make it a little bit more realistic. I have this number 250 people per year, and I want you to change that. So go ahead and scratch it out in your notes. Well, it's not even a scratch out. I just add another 0. So now we have 2,500 people a year are leaving. So 2,500 people per year. All right, so we're going to make a slight adjustment. It just makes the numbers a little bit more realistic. But let's get into the nuts and bolts of the word problem itself now. While you're reading, you want to look for unknowns. And it turns out we have one pretty clear, boldly stated. How many years from now? So let's give it a variable. And let's call it x equals years from now. Okay, so we're not going to say x equals the year. Because if you say x equals the year, that's year 1. If x equals 1, that's the year Jesus was a baby. Okay, so that doesn't make sense for this problem. So we have to be really careful and tell what we mean. We don't mean year 1. We mean years from now. So if x equals 1, that would be 1 year from now. That would be 2024. Okay, so be real careful and think clearly about the meaning of your unknowns. Another thing I'm noticing is some key words here, loss and decreasing. Those two things are kind of reinforcing each other, and they're talking about subtraction. Looks like there's some traction going on here. Other things we can do, let's see if we can put all the pieces together. I have another piece here, 350,000. That is the population now. And then there's this other one, 28,000. That's the population in the future. And the future is unknown to us. We don't know how many years it'll take to get there. Okay, and then we have this one other thing, and it's the thing I changed. It's not 250, it's 250,000 people per year are leaving. Okay. That's it. We've got all the pieces kind of sorted out. Now let's see if we can build an equation here. Now, if you are seeing through the problem right away and you can make the equation straight from this, write it down. But a lot of students, especially when they first get into the world of word problems like this, that's not obvious. And so here is a strategy that can help you. It's called a verbal model. You try to say the words in the whole word problem into a short sentence that's part words and part equation. So I'm thinking, okay, what do we got to do? Well, we have a population now. So I'm going to put down the population now. And then what's going to happen? Well, each year we're going to be decreasing. So we're going to be taking away a decrease of some years. And after a while, that will equal the population in the future. Now, I'm trying to build something here that seems like common sense to me when I take the word problem apart. And it's helping me reduce all the words into a little phrase, pseudo. It's part English, part math. But from that verbal model, I can begin to build my equation. Because I know the population now. It's 350,000. The decrease, though, that I'm not sure what's going on with the decrease yet. So I'm going to hold off on that. But I also know another part of the equation. I know the population in the future. Okay, so we've made some progress here. The only thing that's missing is, what is the decrease? Well, wait, that's another unknown. We don't know how many people were taken off. That is the decrease. Now, this is called a hidden unknown. We don't know what that is. So we had the x, that was our unknown in the question. But now we have another unknown because we don't know how many people to take off. And the problem is because the decrease depends upon the years. And the years are unknown. So how are we going to deal with this unknown of decrease? Well, the best we're going to be able to do is create a little formula for it. Because we don't know the years, and that means we don't know how many people to take off because they're decreasing each year. But we can make a math formula for it. Now, it has something to do with 2,500 people per year. We're losing that many each year. Now, some of you know right away, oh, I know what to do. It's a multiply problem. But some of you may not. So I want to show you another word problem trick. When you're trying to translate word problems and you don't know what the math pattern is, sometimes making a table can help you see the math. EASE. Like, if the year is 1 year, in 1 year, how many people were decreased? Well, they lost 2,500. In 2 years, how many people did they lose? Well, they lost 2,500 the first year, 2,500 the second year. That means they lost 5,000 people. In 3 years, how many people did they lose? Well, they lost 2,500 in each of those 3 years. That's 7,500. Now, what you want to look at is try to figure out what's the math. How do you get from the number 3 to that? What is the math? Well, the math says 3 times 2,500 years. 3 years times 2,500 people is 750 people. The math is multiply. That's going to help me get my formula. Because we don't know the years. The years is x. And we don't know the decrease, but we can make a formula for the decrease because it is 2,500 years times each year. So I'm going to take the 2,500 people per year times each year. And this gives me a formula for the decrease. Now, some of you might know right off the bat, oh, it's 2,500 per year, so I'm just going to multiply 2,500 per year. But some people don't quite see that right off the get-go, and so this little table trick might help you. So that gives me, though, my formula for the decrease. Now, the table is like scratch work, so I'm erasing that to make room for the algebra. And now I think we're ready to start solving here. So I can take the decrease out, put in my formula for the decrease, 2,500x. That tells me the number of people that I'm decreasing after X years. And now we can start solving. Let's minus 3,500 on both sides. And we will get minus 2,500x equals, and then 28,000 minus, I said that wrong, 280,000 minus 350,000 is, be careful with the signs. The 350 is a negative bigger, so my answer is negative 70,000. And we're almost done. We just need to do a division problem here to get x by itself. And you might need a calculator for that. That's okay. There's x. What's a negative divided by a negative? Turns out to be positive. And if you do the division, it turns out to be 28. Sorry, that's a weird coincidence. There's a lot of 28s in this problem. But anyways, that is the answer algebraically. But it's not the full answer if you don't know what 28 means. It means 28 years from now. 28 years from now. The population drops to 280,000 people. There we go. There's the answer to that problem. Okay, I got one more for you. Hang on here. So here's an extra one that's not in our class notes, but it is very similar to one of your mom homework. So I thought I'd give you another example that just might help you think through and get to understand word problems better, and of course to help you with the mom homework on 2.7. So here we go. Let's take a look at this one. Statins are drugs used to keep cholesterol in check and are a top-selling drug in the United States. It's a doctor's drug, so it's not like an illegal drug, but it helps people control the cholesterol that helps their heart. There's an equation here that says x equals negative 0.7 times, I said that wrong. The equation is s minus 0.7 times x, and that equals 4.9. And this equation gives the amount of sales of statin in billions of dollars. And x is the years after 2001. Now, according to this equation, how much did the people spend in the United States on the statin drug in the year 2009? Now, it seems like it might be kind of a hard problem. It's talking about a lot of complex things, but they've given us a formula. And equations that have formulas are actually easier because we don't have to invent the equation. So we already know what the equation is. In previous word problems, we had to make up our own equations. But this one we don't have to. It's based on a formula. But what we do have to understand really well is the variables. And so, like when we start a lot of our word problems, it's good practice to clarify the variables. So S equals the amount of money in sales in billions of dollars. So if S happens to equal 2, that means the company sold $2 billion worth of this medicine. If S equals 13, then they sold $13 billion worth of this medicine. Okay, so we know that from right here. It explained that. Now, there's another variable, X. And I wish we were in class, because in class I would bait you with this and we would have a question, a discussion about this. So I would say, oh, let's try it. Is x equal to years? And we would have discussion about, is that a good explanation of x? And it turns out that is not a good explanation. Because it's, are we talking about what year it is? Years from when? Let me even make it more simple. X equals the year. Well, if I said x equals the year and just happened to come up with x equals 1, what is that? Well, year 1. If x equals 1, that's the year that Jesus was a baby. So that doesn't make sense for this problem. We have to be more careful about the meaning of x. So every word is important. We got to read it carefully. And it does say something more. It says after 2001. When we're explaining x, we're going to have to explain it that way. It is years after 2001. Okay, so they started the whole thing in 2001, and so if x happens to equal 1, then what year are we talking about? Well, we're talking about x equals 1. That's 1 year after 2001. So we're talking about the year 2002. And if x happens to equal 5, what year are we talking about? We're talking about 5 years after 2001, which is 2006. Okay, so let's see if we can figure out this problem. Our job is to find how much did the people spend in the year 2009. So we have to find this S number. That's what we got to find. Okay, so if I start the equation, then S is unknown. Oops, I don't want blue. Okay, here comes another trick. I'm going to try to trick you. Now, X is the year, right? So I'm going to plug in the year. And it says the year is 2009. So, do I plug in the year 2009? Now think about that. Pause for a second. Maybe pause the video and think about, is that good? Did I plug in the right year? Well, I hope you're saying, no, that's not the right year, because I'm saying that X equals the year 2009, and that's not the meaning of X. X does not mean the year. X means the years after 2001. So we don't have the right X number to plug in yet. So we kind of have to think backwards a little bit. If the year is 2009, we got to think backwards and figure out, so what is X? Question mark. Now you might be able to do it intuitively, because the year 2009 and 2001, well, 2009 is 8 years later. Or you could just subtract 2009 minus 2001 and get 8. But either way, what we have here is in the year 2009, then we know X equals 8, because 2009 is 8 years after 2001. So this is my X. This is what I have to plug in. Now, when a word problem has a formula like this, it's really just about plugging in. You just plug in the numbers, and then we're going to solve for S. We're going to get a little bit of algebra here to get S by itself. But we had to make sure we plugged in the right thing. So we had to spend a lot of time understanding what the variable S was and what the variable X was. And so we're ready to start simplifying and solving. So we got 0.7 times 8. That's 5.6. So I'm going to begin simplifying the equation. And S minus 5.6, got one more step here. Let's minus or add 5.6 to both sides. And so we get S by itself equals, carry 1, 10.5. There it is. The algebra is done. But it's not really done if you don't know what it means. So I'd like you to be able to explain the answer. What does 10.5 mean? It means the drug companies sold $10.5 billion of this drug, statin. The drug companies make a killing. I kind of mean that metaphor literally too, but they make a lot of money off of selling their drugs. So there you go. Hopefully that helps. Keep practicing the word problems. You'll get a little bit better each time you do them. Hang in there. See you in class. Bye-bye, everybody.